Hello, this is Andreas Pedersen and Hald here to present our project for computer graphics programming. We've chosen to work with Toon Shaders, also known as cell shaders, and what you're currently seeing is what will be explained and referenced to in code. And so with no further ado, let's get started. The Toon Shader serves the purpose of making digital 3D objects appear as if hand-drawn and thereby cartoonish. Generally, this is achieved using very few colors, typically tones of a single color, making the transitions between colors very abrupt and adding an outline to the digital objects. By doing this, non-photorealistic rendering is achieved. This type of rendering concerns itself with making objects appear obviously different from the appearance of real physical objects. The Toon Shader works very well, very much like the Phong reflection model, except for the three mentioned elements, and then sets up thresholds for different degrees of lighted areas, specular highlights, and outlines. The color tone in the Phong model is determined by the cosine of the angle between a virtual light's direction and the normal vector of the object's surface. The Toon Shader takes this process but adds a threshold determining whether the fragment area should be lit or not. The shader's functionality will be explained more in depth later during the walkthrough of the implemented code. The shader is popular as it is exceedingly simple to create and as such also very easy to individualize in terms of style. Easily customizable amounts and types of colors and thresholds, etc. makes it possible to achieve exactly what animated style one wants. In terms of the strengths and weaknesses of the shader, there are some distinctive ones, however these will be mentioned during the code walkthrough to come. I'll now give the word to Andreas, who will go through the code and explain what happens where.
Thanks, Patrick. Right, I'm going to walk you through the code now for the Toon Shader you see here on the right. We chose to have the specular. There's a little update. Sorry about that. We chose to have the like typical specular highlight, like Phong model, shown here next to it to show like the obvious difference these two iconic shaders have. Now, first of all, I need to add that the code we've written here is taking inspiration in another piece of code, which which was set up to handle multiple light sources with as a Toon Shader. Due to our time restriction on this presentation, we chose to modify the code to only handle the ambient and one light source to stay within our time limits. So if we look here, after the properties have been declared, we start into the vertex shader part of it. Now the vertex shader here takes in a vertex and calculates the position in the world for the vertex, as well as the position for the surface normal vector and the normal vector's direction, as we're going to need them in order to determine whether or not the fragment should be lit or not in the Toon Shader later. But that doesn't happen here until in the fragment shader part, where all the magic happens in the Toon Shader, since it's per pixel shading. Now the fragment shader here takes in the vertex shader's output here, so it receives the vertex output struct, which contained the position of the vector of the vertex and its surface vectors position, as well as direction. Now, first of all, the normal direction here is declared by normalizing the normal vector of the input vertex. Then the view direction is calculated by normalizing the world space camera's position as well, and well, subtracted with the position of the vertex put into the fragment shader here. And well, and light direction and attenuation are declared here as well, but we'll come to that. Like first, the light part here. As mentioned, the code here was is set up for multiple light sources, so it's easily determinable here that we know that we have that we're using directional light, and what that will mean for the calculations to come is that the attenuation is going to be a 1 all of the time. It's a static value that we're going to use with a known direction, where if the light was a point or spotlight, so well, 3D light, then the attenuation would be linear, um, and so the direction would mean a whole lot more. But since we're working with directional light, we'll just carry on now to the more interesting bits. Now, first of all, the fragment color is by default set to be the unlit color, as we see in the example here. It's the dark green color, and in the phone reflection model, it functions the same way. This step is the only one that's completely similar. Now, after that, as you can see in the following conditional here, it checks whether the attenuation, which is 1, so that doesn't matter, times with the the dot product of the surface vectors, well, the normal vector and the light direction. If that's larger than 0, then that will be chosen by the max function. And so if that is greater than or equal to the diffuse threshold, then the fragment color will be set to light color, the light color multiplied with the color chosen for the diffuse color. Now, what it means here with the dot product of the normal direction and light direction is that if the surface of the fragment would pointing away from the light source, as we can see here on the left side right now, well, most of it, then what the math tells us is that that fragment is not in an area that is lit up, and therefore it won't make it light green, where the light green area vector is pointing towards it. Therefore, the dot product of the normal direction and light direction would be greater than 0. And so if that value is greater than the diffuse threshold, then it will be painted light green. After that, it checks if the dot product of the view direction and the normal direction is smaller than the linear interpolation of the outline thickness and the dot product of the normal direction of the surface vector and the light direction, then it will know. Then we'll set the fragment color to be equal to the outline color. Like in layman terms, what it means is that if the fragment is in what appears to be the outline of the object from the point of view that we are seeing it from in the scene, then it will paint it as the outline color, which in this case would make it dark, as you can see here, the thin black dark line around the object. And last but not least, first it checks whether or not the fragment is in a lit area, and whether whether the brightness of the reflection is greater than half of the attenuation, and if the fragment is both within the lit area and it's brighter than um, than half of the attenuation, then the fragment color will be set to the specular color. Well, also involved with some alpha and the previously set fragment color from above, which means that it will. Right now the spec color has been set to be completely white, but since the fragment color in a lit area will already have been set to a bright green color up here, then that will have some influence to it as well. So if we look back here, we can see that since the specular highlight reflection here is not completely white, and that is because of the light green fragment color already computed in it. Now, at the end here, Patrick has some comments to make to the code as well.
Alright, now for this last piece, I'll have the assistance of Andreas while changing some of the code, because while it's very important that each individual piece of the code does what it's supposed to, the overall structure also has enormous importance for this type of code. Now the program code is deliberately setting up the processing of the 4 colors in a certain chronological order. If the 4 code pieces were to be set up differently, for example if the specular highlight was to be set right after the default color, then it would be overwritten by the ambient color, thereby removing it from the final rendering as demonstrated here. And as you can see, the highlight has been removed. And another thing would be that additionally we could also have the shader could also easily have more color tones implemented simply by adding some more threshold layers in proper order, of course. As seen in the outcome block of code here, you can tell that this would actually add yet another layer of highlighted coloring. And in that sense, more colors could be added to this type of coding within mere minutes. With that being said, we come to the conclusion of our presentation, and we hope you enjoyed. That's it.